Alright, welcome to Chapter 3 of Python Essentials 2. And this one we will be going over the concepts of object-oriented programming, which basically has classes, objects and attributes. And we'll be using a stack, which is one of the ways we can handle data, as an example to demonstrate object approaches to this. Then we'll wrap up with properties, which is variables, the difference between instance and class variables and the attributes associated therewith. In the next part, we'll cover methods, inheritance and exceptions. Again, these are fairly large chapters, so we've broken it up in the parts. And in the last session we covered basic exceptions, the way we can handle them, the types of errors, and using the try and except branch methods to handle exceptions so that the program doesn't terminate. And then we had a look through the hierarchy of how exceptions are grouped together and how they can be used to capture multiple types if you want to handle them in a specific way. Okay, basic concepts. Python can be used for object or procedural programming. It handles both quite well. But these operate very differently from each other. So there's a world of data and a world of code. So there's very different approaches to the way we handle these. So with object-oriented programming, we want to change the way we think and the way we handle our code. So data and our code are actually embedded together in classes. So if you think of a class as a recipe to produce a useful product, which is called an object, and these objects are our incarnations or our production of our thoughts and ideas that we express as classes. As I said earlier, there's no real separation under class method, in that our code and our data will be both inside our classes and our objects. So in procedurals we separated the two, and we treated them like we set up our data and then we did our code to make something happen. So what we want to do is set up a series of groupings. So these are categories, and they go from a very generic to a specific subclass. So in the example here we have vehicles, which are separated between land, water, air and space. And then you break those down again into wheel, tracked or hover. And each of these will have inherited products or attributes from its parent. So Vehicles, if you look at this, is what's called a superclass. It's the one that holds all the other classes. So when we look at it like it's the roots of a plant and that it comes down from the top. So all your information is pointing up towards the superclass, which is the top tier of the class. And that's the one that doesn't have any other classes above it. So a class is a set of objects. Each object must belong to a class. And when we create these objects from our classes, we inherit the attributes from that class. So when you come down, like we had vehicles, and then we had land, and then we had specific types, we had wheeled, tracked. So using that example, our vehicles had two attributes, features A and B. Then our land vehicles inherited A and B and added C. And then when we took it out to wheeled, we added D. So as we create more classes or more objects, they inherit the properties from where they've been generated from. So how do you keep track of it? Well, think of it as naming an attribute. So you have a series of properties. So each object needs to be named uniquely, so it identifies what that object is. It has to have its properties that are unique to that object, and maybe it does some activities that are unique to that object. So in the example they give in the material is Rudolph's a large cat who sleeps all day. So the object is Rudolph, his class is cat, his property is that he's a large cat, so the size, and what's he doing? He's sleeping all day. So think about it as breaking it down into your component parts, and then they form the elements that make up the object. So name, properties, activities, or noun, objective, and verb, if you're that way inclined. How do we define a class? Well, it's quite easy. We type in the keyword class, followed by the name that we're giving the class, and follow that with the colon. Now, you then define the attributes and properties of the class. In this example we have in the top right hand corner, we've just basically telling it to pass, which means we're not defining anything at this point in time other than the name. You then have to create an object. So we do this by referencing the class. So we create the name of the object and we tell it it is equal to the class that it's deriving from. and this tells it to inherit all of those properties that are in that class. So if your class is empty, your object is basically empty. If your object inherits those properties from the class. So it's a quick way of duplicating things. Alright, so what's a stack? A stack is the way we store data in a very specific way. It uses LIFO, so last in, first out. So whatever's on top of the stack gets removed first. So think of it as a stack of coins. You don't sort of tend to pull out the bottom coin, you take the top. Alright, you don't selectively take a coin out of the middle. It's just impractical, so you generally take them off the top. Now, to add things to the top of the stack, it's called a push. And to remove the element from the top of the stack is called a pop. So think of a stack as a kind of list. Now, if we're doing it procedural based, we have some weaknesses involved in that list is able to be modified at will by anybody. So it's not a controlled environment. What we do when we add the object-oriented approach to this is we add elements of control. So we protect the data that's in the stack, and this is called encapsulation. So this means it can no longer be modified by external sources if that's what we want. As we are using classes to define objects, such as a stack, we can create as many objects that inherit exactly the same properties as we want. And each time we create a new object, it's unique, has the same properties as the original, and we can do with that as we wish. But the master is never changed. So we're copying and not changing anything. Now, there's a few things we need to have in place to have this occur. We have to have the properties defined in the class. So we need to install a list inside the object, and to do this as we want to be able to replicate it is we don't have a single list. Each object has its own list. We don't want that list available to the users, so it's hidden inside the class. To do this, we have to name it in a strict way, and we need to invoke it in a specific way as well. This is known as a constructor, and the purpose of a constructor is to construct our new objects. And it needs to know everything about the object. So how does this work? Well, we define it with a specific name, which is the double underscore init double underscore. This is a must. It must have at least one parameter to represent the new object, and this enables us to come back and manipulate and make changes as we need. Normally we call this parameter self. It's a convention, but it makes it easier for us when we're coding in this manner. So in the top right hand corner we have an example of class stack. Then we are defining the constructor's name, so we're init selfing followed by the colons. Then we're going to print hi as default for that action for that class. So when we create an object called stack object, which is equal to stack class, we will generate a activity called print hi. Now we can add lists, we can add anything we want into this object, and we need to do it in a specific way. So the convention is to add properties in. We need to put the name and a dot after it. So here we're executing self, then a dot, and then stack list equals. So we're setting property values up for this new object as we've created it, and it will inherit these when the object is defined. So to go through here, we've created a class of stack, and within that we've defined that it will have a list that is empty. So when we create this object and tell it which class we're going to be a member of, and then we've performed a function and we're calling on getting the length and what's the length of the list we want to extract from. So it's stack object and then the specific list after the dot. So we can now access these properties throughout our code. So if you think back to the earlier elements of the course, it's like the methods. Okay, so we're calling functions and methods. That's basically how we did it, wasn't it? So I mentioned earlier that we wanted to be able to encapsulate information so that we can protect it. If we give the name 2 underscores at the start, it becomes private to the class. That means it can only be accessed within the class definitions. So it's not accessible and it can't be modified by any other activity outside of the class. So, jumping back a few slides, we talked about push-pop, adding and extracting elements from the stack. Python assumes that these functions are inside the class body. So if we want to make use of these outside, we need to make them public. In other words, we can't use the double underscores at the start of the name because that makes it private. And it can't have more than one underscore finishing off the name. So as a general rule of thumb, I recommend not using underscores at the start or the end of the name, just to make it easy if you want to be able to make it a usable function outside of the class. Now, as we said, the idea of having a class is that you can create multiple objects that inherit the properties of the class and gives you the ability to then modify or use those different abilities. And we do this by just doing the object name equals the class. Just do that as many times as we need to create the objects that we need. Now, the stack class, if you like, was our vehicles. It was the superclass. Now we want to add subclasses. So this is where we come down and create our land, air, and sea vehicles. So in this example here, we're going to add another class, which is adding stack, which in the curriculum is going to calculate the total of the values in the stack and give you that as a sum. So what we're doing is we're creating a new class, and then inside the parenthesis we're saying what it's a subclass of. So adding stack is a subclass of stack. So you're pointing to the class that it's going to inherit properties from, as that is its superclass. So all the components and properties that are in the superclass will be inherited by the subclass. We want to follow precise rules, or else we'll generate errors. So Python needs you to invoke the superclass's constructor, else you get those errors. So again, adding stack is the class that then we're defining, initializing adding stack as self, and then we want to initialize stack to pull all of that in to this subclass. Now, this only needs to be done within the class definitions. Okay, so when we're doing it, it's only when we're doing it for subclasses. If we're doing it, wanting to use those methods outside, then we don't need this constructor method. This method requires the self argument, and it's got to be first in line. So there's explicit syntax that we have to use when we're dealing with classes, and we need to follow them. Now, once we've defined a function in one of the classes, say in the superclass, for example, we can then reuse those names and repurpose the function, if you like, so that it does something different than what was originally programmed. So we can reuse the name, and this overrides the previous definition. So we're using the same name, and when we invoke it from within a subclass, it's going to do a different function. So in this one, we're redefining push, and it's self-val, so they're the parameters that are available, and we're doing a private variable of sum, and we're adding that to value. So you'll understand the example when you're reading the curriculum, because it's part of the code. But what we've done is redefine this so that each time the subclass wants to use a push, it's doing an extra step while adding up the sums of as it's running through. Now, we're using an private variable within the class, so this can't be used outside of the class. So we need a way of extracting this variable that is private and making it public. So we create a definition, and we make it a public one. So we're defining getSum, and we return self dot and then the private variable. So this makes that private variable that can't be manipulated by anything else outside of the class. By getting it into effectively a public variable, we then have the ability to manipulate the values that has generated within the class by using getSum, which is a public variable that we can use outside of the class. We can then manipulate those values later in other functions. This is a little confusing when you just delve into the theory. It's a lot of it, and it only becomes a little bit more clear when you go through the labs. So at this section, which is the end of section 2, if I remember, there's a couple of labs there which is called Counting Stack and FIFO labs, which go through all of this theory of creating the classes and inheriting the properties. Now, each of these are about 30 to 40 minutes each, and so you put aside an hour and a half to run through the labs. It's highly recommended you do them, because otherwise these are a little blurry. Okay, variables. Now, variables within classes are a little tricky in that we have ones that are called instance variables. So these ones, when we talk about properties of classes, we can interchange the name variable. So every object that is generated from a class possesses properties that are inherited from the class. Now, these are the variables that can be changed. Now, we want to be able to ensure that these properties are member of the object before we utilize them. Each object's properties are its own, so they're associated with the object. Now, when objects are created, we have a predefined set of properties and methods that are always present with the object. One of these is a variable called dict. So underscore dict underscore. So this is a function that exists in each object that gives you a list associated with the properties. There'll be a few activities in the sandpits in the curriculum as you go through it to explain this better. But the ability to use these variables associated with an object is very powerful. So an instance variable must reside inside an object or its methods. You must put the class name before the variable name, and Python will put an underscore at the beginning. Now, this is automatic. The reason Python does this little change to the way you've set out your code is to make it accessible to the outside world. This obviously won't work if you've set the variable to a private. Okay. But if you just use normal variable names, the object, once it's initialized, will create the ability to have those variables accessed outside of the class. Now, the other property that we need to talk about is the class variable. Now, the class variable only resides in the class, so it's not dependent on any object that is generated from the class. So it's unique And here's an example of what I'm talking about. So here we have the class, example class, and we have variable called counter, and it's set to 0. This is a class variable. So when we do a hunt through the dictionaries of objects, we won't see it defined in the objects dictionaries. It is present in all objects, and it will always have the same value as inherited from the class. When we create objects, we inherit properties, but not every property will be the same or existing in every other object. So if we try to assume that things will be there, we can generate an attribute error exemption, which basically means we're trying to access a non-existing attribute of an object. We can try to overcome this problem using our trusted try exempt method of error handling. Is there a better way? I'm glad you asked that, because Python provides a function called hasAttribute, which will return a true or false. So this is the way we check whether an object or a class contains a specific property, i.e. variable. So when we execute this function, we need to provide it with 2 arguments. This is the class or the object being checked, and the name of the property that we are trying to find within that object. Note that we must provide the attribute name as a string. As we said, but didn't really stress that much, is we can operate hasAttributes on classes as well as objects. Just need to stress that a little bit. This way you can find out whether a variable is available. It's nice and easy, returns a true or false, and then you can proceed. So we know how to do conditional statements, so we can set it up so that if true, it's going to do this function. If false, it'll do something else. So in summary, I'll say that we have basically gone through lots of theory today. A lot of new concepts to get your head around. So we went through the fact that classes exist and subclasses that generate objects from those, and that classes, objects, have attributes that we can control, and we went through some examples of how object orientated is different using the stack example. And then we had a brief introduction into some of the properties, being instance and class variables and the attributes associated with those. In part 2, we'll continue on with methods, inheritance and exemptions. Till then, I think that'll do us.